Okay, this tutorial is about solving a variable length subnet mask problem for the Cisco CCNA. Now this example right here is an example of one of the harder types of problems you're going to find on the Cisco CCNA that relates to variable length subnet masks, or VLSM. So in the question, what we have here is we've got a network diagram here, and you've got to basically look at the network diagram, and it tells you that in the question, let's say, we need to find the missing subnet right here. You see this one has a question mark. And for this missing network, this missing subnet, we're going to need about 14 users here, or 14 users. And we need to have the network size, the subnet size, have the fewest wasted addresses. So it needs to be as close to 14 users as possible. Now let's examine this network diagram. We've got 1, 2, 3, 4 routers here interconnected. Now, in between these two routers and these two routers is WAN links. Okay, you can see these serial WAN links. These are evidenced by this lightning bolt. And so these are point-to-point links. And you can see here there's a subnet here for it. It's been /30 subnet mask, right? So they've got two small subnets for this two point-to-point links. And then coming off of this router over here, we've got a subnet /26. Coming off of this router over here, off of its Ethernet interface, we've got another subnet /28. Then in between these two routers, we have another network that is not a serial network, but it's, let's say, another Ethernet network here /28 subnet. Then coming off of this router here at the bottom, /26 subnet, and coming off of this router over here, /26 subnet. Then in between these two routers, you've got an Ethernet network over here. Notice the straight line connecting these two, not a lightning bolt. And this is the missing subnet that we have to find. And so in the question, in this type of a question, they'll give you choices for answers. So here's your choices. Which one is the correct answer? A, B, C, D, E, or F. So I'm going to show you how you would approach this type of problem, okay? And basically find the missing network and find it quickly. Okay, so if you look here, you'll see that all of these networks are subnets off of the 192.168.5 network, right? So we started with the 192.168.5.0, and we've subnetted it into these different subnets. And it's variable length subnet mask because this is a /30 subnet mask, /30 subnet mask. These are /28s, and these two are /26. So we're using different size subnets in this 192.168.5 network space. So we have to figure out what is left over that we can use here, right? So first of all, the question gives us a hint. It says the missing subnet needs 14 users. So right off the bat, that tells us what slash we're going to need. What slash? /30, /28, /26, /27. What are we going to need? Well, we go down here to our binary chart here, and we'll see here we've got the twos, these binary place values of 2 to the 0 to 2 to the 7th power. And these are the binary place values. So we need to find out what will our subnet mask be. Well, if we look down here in this little box here I've created, you can see here I've got the binary place value system. So 2 to the 0 is the 1's place. 2 to the 1 is the 2's place. And all the way up to 2 to the 7th power, which is the 128's place. So 2 times 2 times 2, 7 times is 128. And then I've made here a binary subnet mask of 1's and then 0's. So this would be 255, and then these 8 1's is 255, and then these 8 1's is 255, and then these 0's is 0. So this would be 255, 255, 255, 0, right? Or this would be a /24 subnet mask, okay? Now each group of 1's, so this group right here, if you have 1's in all 8 places, you have 128 plus 64 plus 32 plus 16 plus 8, 4, 2, and 1 equals 255. So that makes 255, 255, 255, 0. We look at our place values, and we see that on the 2 to the 4th place value, right, 2 times 2 times 2 times 2 is 16. That's the 16's place value. That's the size network we're going to need. Because you can't use the first address, because that's the network address. You can't use the last address in the subnet space, because that's the broadcast address. So 16 minus 2 would be 14 usable hosts. So that would be perfect for a size 14 network. So to do that, your subnet mask would look like this. Okay, I had 4 ones here, right? And now it would be a 255, 255, 255, 240 network, or we'd call that 25, 26, 27, 28, a /28 size subnet. So the correct answer is going to be a /28. So right off the bat, we know that this answer right here, right, the /26 answer is wrong. And so I will just make that red. That's wrong. And we know that this /27 is also wrong, right? So I'll make that red. So we know that those two answers are wrong. So we're looking for one of these other B, C, E, or F has the right answer. And so now what we'll do is we'll start examining this diagram to see if we can narrow it down even further. All right, so let's look right off the bat at this bottom network, 192.168.5.64/26. Okay, so we want to find out how big is this subnet? We know it starts at 64. We know it starts at 64, but how big is this? What is this network address space, right? So if it starts at 64, right? And what I'll do here, okay, if it starts at 64, how big is this address space? Well, we have to figure that out by looking at the subnet mask, /26. We look at our chart here, and we can see that if we had 8 bits here, 8 bits here, 8 ones here, that's /24, right? 25, 26, like that. That's a /26. Okay, 26 ones and 6 zeros, right? And we see that in this last octet right here, we've got 2 ones, which would be the 128's place and the 64's place. So the magic number, this last borrowed bit, this last one is in the magic number position, which is the 64 position, right? So 1, 2, 1, 2. And so the network is size 64, magic number 64. That means the network if it starts at number 64, it's going to go all the way to 127, because 64 plus 64 would signal the next network, and the next network would start at 128. So we know that this network right here, the 64 network, right, size 64, is from 64 to 127. So we know if we look up here at our choices that the 112, right, this choice B here, is already being used by the 64 network. So this one is no good. So this problem right here, this answer right there, is incorrect, right? Can't use the 112. It's already being used by this network here. All right, let's apply this principle again. We'll go over here to this network right here, 192.168.5.128. It's also a /26. Well, we just did that. We put out here 26 ones in a /26 network. We saw that the last octet, these two ones occupy the 128 and the 64, and the last one is in the 64's place, which means the magic number 64. So that means that this network right here that starts at 128 goes to 191, because if I add 64, I say that the next network is 192. So this /26 network goes from 128 to 191, all right? And that means that this 160 right here, if I look up here in these answer choices, you see this choice C is a 160, that is impossible because it's already being used by this network over here, which goes from 128 to 191. Okay, so this is the wrong answer. Okay, so that's the wrong answer also. All right, now it gets a little tricky. We have two choices, down to 224 and 240, right? And we're going to say here that this is /28, so we know it's the right size subnet mask, right? We know that /28, by the way, that subnet mask, if I put it down here, and just to prove a point here, /28. Okay, the last one is in the magic number position 16, right? The last borrowed place value here is 16. So we know that this network that they want to create here is going to be a size 16 network. So let's see if 240 would work. If the network has a 240 number, right, and it's going to be size 16, it would go from 240 to 255. It would go all the way to the end of the address space. It would go from 240 to 255 because that's 16 numbers. 240 to 255 is 16 numbers, /28, size 16 network, right? And we know that if this was the network, that it would not work, because if you look up here, you can see that we've got a 248 network /30, and we've got a 244 network over here, also /30. And so if this was the right answer right here, it would actually conflict with two existing networks. So we know now that this network is also a wrong answer. And that leaves one possible answer left, right? That leaves one possible answer left, the 5.224 network /28. And if we draw it out here, I'm going to draw it out here, we know that it's size 16, magic number, place value is 16, so we know it would go from 224 to 239 because the next network, 224 plus 16, is 240, right? So we know it would go from 224 to 239, 224 being the network number, 239 being the broadcast number, and /28, right? And we look around here and we can see that 224 to 239, that there are no other networks that occupy that address space, right? So that it would work.